So, hello student. In the series of previous year question, we are discussing important question of motion in a straight line of the physics chapter. Now, in this chapter, we will finish that chapter. Okay, so we will discuss all type of question related to this chapter, related to that chapter. Okay, now we will start with the first question. So, the first question is asking a ball is thrown vertically upward with a velocity of 20 meter per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meter per second square. A ball is thrown vertically upward. A ball is thrown vertically upward with a velocity of 20 meter per second from the top of multi-story building with a velocity of 20 meter per second from the top of a multi-story building. The height of the point the height of the point from where the ball is thrown the ball is thrown is 25 meter from the ground. 25 meter from the ground. How high will be the ball rise, and second one is how long will it be before the ball hits the ground. The ball hits the ground. Take g equal to 10 meter per second square. So what the question is asking, a ball is thrown vertically upward with a velocity of 20 meter per second from the top of a multi-story building. Okay, so it was thrown with a velocity of 20 meter per second. Okay, its acceleration is downward and acceleration due to gravity is downward. So in that case, we will take the value of g as positive. G is equal to 10 meter per second square. Okay, and its initial velocity is 20 meter per second. And what we have given, the height of the building, that was 25 meter. Okay, so next we have given, we have to find the maximum height. Maximum height from the top of a building. Okay, okay, okay. Oh wait, huh? Sorry, I have made wrong diagram. Maximum height means it was thrown firstly upward, then it thrown downward. So what is the maximum height from the building? So V is equal to H is equal to UT plus half, sorry, V square minus U square is equal to 2GH. So V square minus U square is equal to 2GH. We know that V is 0, so we will take V as 0. Now US 20 square is equal to 2 into G into H. In that case, we will take GS minus 10 because ball is moving upward and acceleration due to gravity is downward. So minus 20 H is equal to minus 20 into 20. So minus minus will be cancelled, 20 will be cancelled. So height will be rise by ball is 20 meter. Now second case in which how long will it take before the ball hits the ground? So second one is for a ball projected from projected from the top of the tower of the building. The top of the tower of the building. Top of the tower of the building. So in this case, we know that S is equal to UT plus half GT square. Okay. So the value of S is H minus UT plus half GT square. Because if we throw a ball downward, so its velocity will act freely. Okay, that's why we will take its minus. So height is 25, U is 20 into T plus half 10 into T square. So on cancelling, you will get 25 is equal to minus 20T plus 5T square. So if 25 will come here, so 5T square 5T square minus 20T plus minus 20T minus 25 is equal to 0. So if you take 5 common, so T square minus 4T minus 5 equal to 0. So T square minus 5T plus T minus 5 equal to 0. So T is equal to 5 or T is equal to minus 1. Okay. So minus 1 it will not be the answer. Time is always positive. So time required to hit the ball is 5 seconds. Now move to one concept, motion of a body under a, under a gravity, under the action of a gravity. We know that the three equations of motion are V is equal to U plus AT. Second one is V square minus U square is equal to 2AS. Third one is S is equal to UT plus half AT square. Now consider the first case when a body is thrown vertically upward, thrown vertically upward, vertically upward. So if a body is thrown vertically upward, so what will happen? Its initial velocity is upward, it is moving upward, and acceleration due to gravity is moving downward. So in that case, we will take A is minus of G, and V is your initial velocity, S is your H. So the first equation of motion will be your V is equal to U minus GT. Second equation of motion will become V square minus U square is equal to minus 2GS, 2GH. And third equation of motion will become H is equal to UT minus half GT square when a body is thrown vertically upward. Now, next case is when a body is thrown vertically downward. Second case is when a body is thrown vertically downward, thrown vertically downwards, vertically downwards. So when a body is thrown vertically downwards, so what will happen? It will move downward. Its initial velocity is downward. Its acceleration is downward. So in that case, we will take the value of acceleration as g because it is moving in the direction of acceleration. So the first equation of motion will become v is equal to u plus gt. Second equation of motion is v square minus u square is equal to 2gs 2gh. Third equation of motion will become h is equal to ut plus half gt square. So that was the equations of the motion when a body is thrown vertically downward. Now the third concept, when a body falls freely. When a body falls freely. If a body is falls freely, what it means? That it does not require any velocity. So u is equal to 0 in that case. Okay. So the first equation of motion will become v is equal to gt. Second equation will become v square is equal to 2gh. Or you can say that v is equal to under root of 2gh. And third case, h is equal to half gt square will be the equation of motion when a body falls freely. So these are the types of equation of motion. First is normal equation of motion, v is equal to u plus at, v square minus u square is equal to 2s, s is equal to ut plus half at square. First case is when a body is thrown vertically upward. So the motion of the body is upward and the acceleration due to gravity acts downward, means both are in opposite direction. So that's why we will take acceleration as minus g. So in place of acceleration you can put minus g, and in place of s you can put h. H has a height, means in motion vertically upward and downward motion, so the displacement will be height of the height covered by the body. So the first equation of motion will become v is equal to u minus gt. Second equation will become v square minus u square is equal to minus 2gh. Third equation will become h is equal to ut minus half gt square. And when a body is fall downward, so acceleration due to gravity means g, and the motion of the body as both are in downward direction. So the equation of motion will become v is equal to u plus gt. V square minus u square is equal to 2gh, or h is equal to ut plus half gt square. And when a body falls freely, that means its initial velocity is 0. So the equation is v is equal to gt, v square is equal to 2gh, and h is equal to half gt square. Now the next question is, I think this concept will be clear. Next is explain the term the average velocity and the instantaneous velocity when they are equal. Next question is explain the terms the average velocity, the average velocity and instantaneous velocity, instantaneous velocity when they are equal. When they are equal. Wait 1 minute. I am plugging the charger. Now first is your average velocity. Average velocity. So what is the average velocity? The average velocity of the particle, the average velocity of the particle is defined as the ratio of total displacement, or you can simply say that displacement delta x to the time interval delta t. Time interval delta t. So the average displacement is equal to delta x upon delta t. Now next is your instantaneous velocity. Instantaneous velocity. Next topic is your instantaneous velocity. So what is instantaneous velocity? When the time duration is very short, so the displacement of the ratio of displacement upon time at that time is known as the instantaneous velocity. So the velocity of particle, the velocity of a particle at a particular instant of a time, at a particular instant of a time is known as instantaneous velocity. Instantaneous velocity. So its formula is limit delta x tends to 0, sorry, delta t tends to 0, delta x upon delta t will be the value of instantaneous velocity. Okay, it may be positive, negative, or positive or negative in a straight line. So when they are equal in a uniform motion, in a uniform motion, the instantaneous velocity of a body, the instantaneous velocity of a body is equal to the average velocity. Now the next question is, state Newton's second law of motion, hence derive the equation of motion F is equal to ma from it. I have discussed it earlier. So firstly, I am writing the question. State Newton's second law of motion, Newton's second law of motion, and hence derive the equation, hence derive the equation F is equal to ma from it. Ma from it. Now, what is the Newton's second law of motion? So, Newton's second law of motion states that force is the rate of change of linear momentum of a body is directly proportional to force applied on a body. So, what is the Newton's second law of motion? The rate of change of the rate of change of momentum of a body, the rate of change of momentum of a body is equal to, sorry, is directly proportional, is directly proportional to the external force applied on the body. To the external force applied on the body. Applied on the body. So the force is directly proportional to dp by dt. After removing the sign of proportionality, a constant will become k dp by dt, and k equal to 1. K equal to 1. So F is equal to dp by dt. P is momentum. We know that P is equal to mass into velocity, and mass will be a constant quantity. So F is equal to d by dt of mv. M is constant because mass is always constant into dB by dt. dB by dt is velocity, rate of change of velocity with time, which is equal to acceleration. So force is equal to mass into the acceleration will be its proof. Okay. Now next question is, comes to short answer, very short answer type question that are one number question. Okay. So the first question of that was the states of motion and rest are relative. Explain. The answer of that question will be rest and motion are relative. Rest and motion are relative. Are relative. Means they are related with one another. Okay. So they are not absolute. They are not absolute. A body can be in a rest. A body can be in the rest or in a motion with respect to reference frame. Reference frame. Okay. A man is moving. A man in a moving train. A man in a moving train is at rest with respect to co-passenger, but he is in motion. But he is in motion with respect to man on the ground. Okay. So that was the relation between motion and the rest. Means if a person is sitting on a train, so he will be rest with respect to person B. Okay. But if a person C is watching from the outside of the train, then he can see that person A is in a motion. So that was the frame of reference. Now next question is, next very short answer type question is, give an example, give an example where the velocity, where the velocity of an object is zero, but acceleration is not zero. But acceleration is not zero. So in the projectile motion, at the highest point, the velocity will be zero, but its acceleration will not be zero. Okay. In the next video, I will discuss about what is the projectile motion. In that topic, you will clear about it. Okay. So when the body is projected vertically upward, at its highest point, at its highest point, its velocity is zero. Its velocity is zero, but its acceleration a is equal to g is not equal to zero. Okay. Now the next question is a vehicle a vehicle travels half the distance L with a speed v1 and other half with the speed v2. With the speed v2. What is the average speed? So average speed is total displacement upon total time. What is the average speed? So that was suppose L distance from A to B, it will be L distance. So it cover half distance, that means L by 2 with the speed V1 and half distance L by 2 with the speed V2. So what it means, the average, what do you mean by average speed? Average speed is total displacement upon total time. So average speed is total distance upon total time. Total distance upon total time. So here time is not given. We know that speed is equal to distance upon time. So V1 is equal to distance is L by 2 of time 1. So time 1 is equal to L by 2 of V1. Similarly, time 2 is equal to L by 2 of V2. So total distance is L by 2 plus L by 2 upon L by 2 of V1 plus L by 2 upon V2. So L by 2 plus L by 2 will become 2L. And in a denominator, you can take L by 2 common. So 1 upon V1 plus 1 upon V2. Sorry, L by 2 plus L by 2 is L. Okay. Since L by 2 plus L by 2 is equal to L, so we will write here L. Okay. So now L will be cancelled. So 2 upon V1 V2 V1 plus V2. So if that will come in the upward, so 2 V1 V2 upon V1 plus V2 will be the average speed. Come to the next question. Now the second question is of your short answer type question. So the question is, a ball is dropped, a ball is dropped from a building simultaneously, from a building, and simultaneously another ball is projected upward. Another ball is projected upward with some velocity. Describe the change in relative velocities of the ball as a function of time. As a function of time. Okay. Now suppose that was the building and a ball is dropped from that building. In the same time, a second ball is thrown upward. So for ball one, for first ball, which was thrown from down upward. Okay. So U is equal to U1, V is equal to V1, and A is equal to G. Because it is moving downward and acceleration due to gravity is downward. And it is moving upward and acceleration due to gravity is downward. So for first of all, U is equal to U1, V is equal to V1, A is equal to G, and T is equal to T1. So substituting the values, we will get V is equal to U plus in V is equal to U plus AT. So we will get V1 equal to U1 plus GT1. That was its equation first. Now for the second ball, which was thrown upward, for second ball, which was thrown upward. So for the second ball, what will happen? Second ball, which was thrown upward, in that case, U is equal to U2, V is equal to V2, A is equal to of minus G, and T is equal to T2. Why I am taking as minus G? Because the ball is moving upward and acceleration due to gravity is acting downwards. Okay. So on substituting V is equal to U plus AT, you will get V2 equal to U2 minus GT2. That was your equation second. Now subtract equation first, equations first from equation second. Subtracting, subtracting equation first from equation second. So V1 minus V2 equal to U1 minus U2 plus GT1 minus T2. Okay. So what do we get? V1 minus V2 is equal to U1 minus U2 plus G T1 minus T2. If that term come to left hand side, so V1 minus V2 minus U1 minus U2 is equal to G of T1 minus T2. That means what is this? This is the relative change in relative velocity. Okay. So change in relative velocity. Change in relative velocity. And what is this? The function of time. So we have proved that the change in velocity is in the function of time. Okay. So we can write it by, you can write it that the change in velocity, the change in final relative velocity, final relative velocity and initial velocity of the two is function of time. Okay, so that are the some important questions. Now come to next question. When a bullet is fired from a gun, is fired from a gun, the gun gives a kick the backward direction. In the backward direction. Explain. Now suppose that was a gun. When a bullet is fired from it, so what will happen? So the mass of the bullet is less, so its velocity will increase, and the mass of the bullet is high. Mass of the gun is high, so its velocity will be less. So due to the law of conservation of momentum, we get a backward force on when we fire a bullet from a gun. So due to the due to law of conservation of momentum, due to law of conservation of momentum, recoil of gun will happen. Recoil of the gun is happen. Now second question is, if a bomb at rest explodes into two pieces, explodes into two pieces, the pieces must travel in opposite direction. The pieces must travel in the opposite direction. How? So the reason is same. According to Newton, according to law of conservation of momentum, according to law of conservation of momentum. So this is bomb. Initially, it has reds. So its velocity will be zero. So after exploding, one part moves with direct direction, one part moves with that direction. So m1v1 is equal to the mass of that part is m1 and the velocity of that part will be v1, and the mass of that part will be m2 and the velocity of that part will be v2. So according to law of conservation of linear momentum, the initial momentum of a body is equal to the final momentum. So mu equal to m1 v1 plus m2 v2. So we know that the body is at rest. Initially, the bomb is at rest. Initially, the bomb is at rest. The bomb is at rest. So this term will be 0 because u equal to 0. So m1 v1 equal to m2 v2 plus m2 v2. So m1 v1 is equal to minus of m2 v2. So that's why they are traveling in the opposite direction, because negative sign indicated that the negative sign indicates that the pieces must travel in opposite direction. Opposite direction. So that's we have discussed all the important question from that chapter. Now I'm coming to a first chapter. There are small one number question that the discovery of CV Raman, etc. So that was not a bigger topic. So I am writing answer in this video of that question. Firstly, I discuss the question that are only two and three question, and you have to remember in your examination. Well, they are not a much big chapter to explain. Okay, so you have to remember directly the answer of that question. So the first question is of your first chapter is, what is the discovery of CV Raman? What is the discovery of CV Raman? What is the discovery of CV Raman? So the discovery of CV Raman is in elastic scattering of light by molecules. In elastic scattering of light by molecules. Just wait. What is global warming? What is global warming? You have to remember all these answers, huh? That are coming your one number questions and that are not too much to explain. Okay. So what is the global warming? Average increase in temperature of Earth surface of Earth surface due to greenhouse gas effect. Due to greenhouse gas effect is called global warming. Is called global warming. Next question is, what is the contribution of S. Chandrasekhar to physics? So the next question is, what is the contribution What is the contribution what is the contribution of S. Chandrasekhar to physics? S. Chandrasekhar to physics. So while studying the contribution of the stars, he has proved that the maximum mass, the maximum mass that a white dwarf can have is 1.4 times the solar mass. This mass is known as Chandrasekhar limit. This mass is known as Chandrasekhar limit. If I star crosses this limit, it has to face a catastrophic collapse. Now, second question is define unified atomic mass. Define unified atomic mass and write its value in kg. And write its value in kg. So, what is the unified atomic mass? One unified atomic mass unit, one unified atomic mass unit is defined as 1/12 mass of the carbon atom. 1/12 mass of C12 atom. Mass of C12 atom. So one atom mass unit is equal to 1.66 into 10 to the power minus 27 kg. So that are the some important question of your first chapter. If I find any another question of the first chapter, so I will share the question with you. Okay. So that's all for today. If you have doubt in any topic or in any question, so you can send that doubt to sir or madam. They will follow. They will forward me, and I will give provide you solution of that question or doubt in